In this video, we look at the homework problems coming out of section 11.5, which covers matrices and matrix operations. Let's take a look at problem number 1. Perform the matrix addition or subtraction. In a matrix, you have rows and columns. Each row is the numbers going across horizontally, and each column are the numbers coming down vertically. To add two matrices, they have to have the same number of rows and same number of columns. When we write the size of a matrix, we express it as the number of rows times the number of columns. That makes the matrix A a 2 by 2, 2 rows by 2 columns. Matrix B is also a 2 by 2, represented by 2 rows by 2 columns. In order to do matrix addition or subtraction, we must have exactly the same dimensions. Then we simply add or subtract the elements in each position. This means that matrix A plus matrix B is simply equal to a 2 by 2 matrix consisting of 4 minus 7, 2 minus 4, 5 minus 6, and 4 plus 1. When we combine these together, we get another 2 by 2 matrix with the numbers -3, -1 in row 1, and -2, 5 in row 2. This is because we added the elements in row 1, column 1 together to get -3. Row 2, column 2, we added those together to get the number in row 1, column 2. Then we added the numbers in row 2, column 1 together to get the number in row 2, column 1, and the number that was in row 2, column 2 was added to the other number in row 2, column 2 to get that value. That's really all there is to matrices. They're a lot of fun and actually quite easy. Let's look at number 2. In number 2, we want to again perform the matrix addition or subtraction. In this case, we want to do subtraction. So we have the 2 by 2 matrix, 5, 5, 7, 2, if we read across the rows. Again, this is 2 rows by 2 columns. To add or subtract, it has to be added to another 2 by 2 matrix. Matrix B is also 2 rows and 2 columns, so we can combine them together. We will take each element in the same row and same column and subtract the second one from the first. This will give us an element in another 2 by 2 matrix, which is the value of A minus B. In our case, this is 5 minus 4, which goes in the first row, first column. This will result in the value of 1 being in row 1, column 1. Then we take the number in row 1, column 2, 5 minus 8. This will give us the value of -3 in row 1, column 2. Then we take 7 minus a -2. Remember that when you subtract a negative, it gives you a double negative, which makes it actually add, and we get 9. Then for row 2, column 2, we have 2 minus a -3, which again gives us another double negative, resulting in addition, which gives us the number 5. That's all there is to matrix addition and subtraction. Now let's look at problem number 3. Problem number 3 is also matrix A minus matrix B, but the sizes or dimensions of our matrix have changed. Matrix A is now 3 rows by 2 columns, or a 3 by 2. Remember that it has to be row and then column, or RC Cola or Roman Catholic Church, whatever it takes to remember it. When we look at matrix B, we also have one that is a 3 by 2, since we have 3 rows and 2 columns. Then we can combine the values in the appropriate positions in each matrix. We'll write down columns for A and B and then combine the elements together. Since we're subtracting, we're going to take all the elements in matrix B and subtract them in the same position from the element in matrix A. Pause the video here, work out your solution, then turn the video back on to see if your answer matches mine. Notice that you have several elements where you have a double negative. Make sure that the double negative results in adding the second term instead of subtracting. Did you get the same answer I did? Let's take a look now at the next problem, problem number 4. In this problem, we want to use the matrix to perform scalar multiplication. A scalar is another way of writing a constant. A scalar is a constant value like the number 3 or 5. In this case, we want to multiply matrix A by the number 3. We can represent this by putting the 3 on the outside of the matrix, like this. Notice that matrices can be written with either square brackets or round parentheses. You'll see both used. This time I'm writing it in square brackets on the left and round parentheses on the right. In this video, I'll mostly use square brackets since that seems to be what the book does. But be aware that sometimes other people and other textbooks will write them with round parentheses. When you have a scalar on the outside of a matrix multiplied by the entire matrix, you basically multiply every element on the inside by that value. This gives us 3 times negative 8, 3 times negative 2, 3 times the 4, and 3 times negative 2. Representing all of this, then, we come up with the final value of this 2 by 2 matrix of negative 24, 12 reading across row 1, and negative 6 reading across row 2. Now let's move on to problem number 5. In problem number 5, we have our first example of matrix multiplication. To do matrix multiplication, the number of columns of the first one must match the number of rows of the second. One way of expressing this is by writing them side by side like this. Remember, it's RC, row and then column. This is being multiplied by a 2 by 3 column. Notice that in order for the multiplication to be defined, the number of columns of the one on the left must equal the number of rows of the one on the right. In other words, this pair must match. The result then will be a 2 by 3. This will be given by the outer pair that you have here. When the inner pair match, the product gives you a matrix of the dimensions of the outer pair. Now, matrix multiplication is far more complicated than matrix addition and subtraction. You're going to take your first row and multiply by the first column. In other words, we're going to take the negative 4, 3 and multiply by the 1, negative 2. We'll add each of the products together, and that will go into the 1, 1 position, row 1, column 1. I used row 1 on the left and column 1 on the right. Think of going across the row and down the column. In other words, we're going to have negative 4 multiplied by the 1 added to 3 multiplied by the negative 2. All of this goes into the first row, first position. Now we want to multiply the first row by the second column. Again, we move across the row and down the column. This is going to be in row 1, column 2, which is the next slot over. This will give us the negative 4 multiplied by the negative 3 and the 3 multiplied by the negative 8. These products are added together. For the next position in the 2 by 3, we need to have it here in row 1, column 3. We use row 1 on the left and column 3 on the right. Now we want to multiply the -4 by the 1 and the 3 by the 8 and add the products together. This gives us -4 times the 1 plus 3 times the 8. In order to find the values coming out of row 2 in our 2 by 3, I need to use row 2 from the first matrix on the left. This will give me the -6, -6, and I start over again with column 1. The -6 will multiply by the 1, the second -6 will multiply by -2. This will give me a -6 multiplied by 1 added to the second -6 multiplied by -2. Now to find the element that goes in row 2, column 2, I still use row 2 from the matrix on the left, but now I use column 2 from the matrix on the right. Multiply the -6 by the -3 to get the first product. Then multiply the second -6 by the -8 to get the second product and add the two together. Finally, to get the last element, we need to multiply row 2 on the left by column 3 on the right. The first -6 multiplies by 1, and then we multiply the second -6 by 8 to get the second product in that element. Now that we have all the values written down, we can do the arithmetic and find the value of the 2 by 3 product of matrix A left multiplied by matrix B. Be careful. Matrix multiplication is not usually commutative. A times B does not equal B times A the vast majority of the time. This will give me a -4 plus 3 times -2 is -6. This combines to give me -10 in the first row, first column position. On the next element over, in column 2 of row 1, I have -4 times -12, which is 12, and 3 times -8, which gives me -24. 12 minus 24 gives me a -12 for the row 1, column 2 element. Looking at row 1, column 3, I have -4 times 1, which gives me -4, plus 3 times 8, which is 24. This gives me the value of 20 to go in row 1, column 3. Repeat the process on row 2 and see what values you come up with. I have -6 plus 12, which gives me a +6 in row 2, column 1. 18 in row 2, column 2, being added to a +48 results in 66 to go in row 2, column 2. Finally, -6 minus 48 gives me a -54 for the element in row 2, column 3. Again, matrix multiplication is far more difficult than matrix addition or subtraction, but it can be kind of fun. Make sure that you write the order down and the dimensions in the order that they're being multiplied. The inner pair have to match, and then you get the outer pair as the dimensions of the product. Let's take a look at the next example, number 6. Use the matrices below to perform matrix multiplication. Let's first write the dimensions so we know what the dimensions of the product are. This has 2 rows, so it is a 2 by, and it has 3 columns, so it's a 2 by 3. Now we want to multiply the 2 by 3 on the left by this matrix on the right. This has 1, 2, 3 rows, which is going to give us a 3 by 2 columns. What is the result of a 2 by 3 times a 3 by 2? The inner pair have to match or the multiplication is not defined. The dimensions of the outside are a 2 by 3, so we'll get a 2 by 3. Now what we're going to do is we're going to set up and find the elements in each one. Again, we want to take the row on the left, RC, by the column on the right. This is going to give us 6 times negative 4 plus 3 times negative 7 plus negative 7 times 1 to go in the row 1, column 1 element. Now we use row 1 but column 2. This will give us 6 times the negative 2 plus 3 times 6 plus the negative 7 multiplied by negative 8. This goes in row 1, column 2. Then we go back to the beginning and we pick up row 2 to multiply by column 1. This gives us 4 times negative 4 plus 1 times negative 7 plus negative 2 multiplied by 1. Then we'll use still row 2 on the left, but column 2 on the right. Then we multiply each element in order together and add the products. This gives us 4 times negative 2 plus 1 times 6 plus a negative 2 being multiplied by negative 8. Now take a moment to work out the arithmetic. Note that you do end up with a 2 by 2. You may want to go ahead and write these down in a different color so that it's easier for you to do the addition and arithmetic. This would be negative 24 minus 21 minus 7. When you take a negative 24 minus 21 minus 7, you get the value of negative 52. This goes in row 1, column 1. Then we can take the negative 12 added to 18, which gives us 6. Negative 7 times negative 8 is a positive 56. This gives us the value of positive 62 to go in row 1, column 2. 4 times negative 4 is negative 16, minus 7, minus 2, which gives us negative 16 minus 9, or negative 25, to be in row 2, column 1. Then we have negative 8 plus 6 plus 16, which gives us negative 8 plus 22, which gives us 14 for row 2, column 2. This represents the 2 by 2 product of left multiplication by A onto B on the right. Let's now look at the next problem, number 7. In number 7, we want to use matrices to perform the indicated operations. We want to add A and B and subtract C. This is not matrix multiplication. This is matrix addition and subtraction, so they all need the same dimensions, which in this case is 2 by 2. Since we're adding and subtracting 2 by 2s, we should end up with a 2 by 2. This gives me 7, 5, 2, 1, plus, on the next value, 2, 8, negative 4, negative, oops, I'm reading in columns, 2, negative 4, 8, negative 4. And then we subtract from that negative 6, 6, negative 3, negative 7. You can do the mathematics in your head, but on the exam, I advise that you write down each element to be sure that you don't make a careless mistake. 7 plus 2 minus a negative 6 will give us a double negative, which will make that one add. That will give us 9 plus 6, which gives us 15 in the row 1, column 1 position. Then 5 for row 1, column 2, plus a negative 4 or minus 4 minus 6 will give us 5 minus 4 minus 6, which gives us a negative 5 for the row 1, column 2 position. In the bottom row, we'll have 2 plus 8 minus a negative 3. Make sure on the exam that you write it down so that you can be sure to get partial credit. The double negative makes it plus, and that will give us 13 for the row 2, column 1 position. Then we have 1 plus a negative 4, or 1 minus 4, minus a negative 7, which gives us a double negative, or plus 7. This gives us negative 3 plus 7, which gives us the value of 4 for row 2, column 2. Let's take a look now at problem number 8. In problem 8, we are again to use the matrices to perform the indicated operations. This time we want to do scalar multiplication of C by 2, then add B to it. This means we're going to take 2 on the outside of our C matrix, negative 5, negative 5, 3, 5, and then we're going to add to this the B matrix, which is negative 8, negative 8, 4, 5. Remember to do the multiplication by the scalar first. When we multiply by the scalar first, we end up with negative 10, negative 10, 6, 10 for the first matrix being added to the second matrix, which is not changed. When we evaluate this by adding together the elements in the same position, we will again end up with a 2 by 2. Negative 10 minus 8 gives us negative 18. Negative 10 minus 8 is still negative 18. 6 plus 4 gives us 10, and 10 plus 5 gives us 15. This is the resulting 2 by 2 matrix from combining a scalar times a 2 by 2 plus another 2 by 2. Let's look at the last problem in this homework set. Problem number 9 asks us to use the matrices to find the indicated operation of a squared. Realize that a squared does mean a times a. This means that we want to write it 2 times, so we have negative 3, 1, negative 7, negative 6, being multiplied then over here on the right by the same thing, negative 3, negative 1, negative 7, negative 6. The first time we're going to use row 1, column 1. Remember to multiply each element in order together. Since we have a 2 by 2 being multiplied by another 2 by 2, and the inner pair match, we'll get the outer pair of a 2 by 2 as the resulting product. This gives us negative 3 times negative 3 plus the negative 1 times negative 7 to go in the row 1, column 1 position. Now let's use column 2. Negative 3 times negative 1 added to negative 1 times negative 6. This will go in row 1, column 2. Now let's go back to the beginning and use row 2 times column 1. This will result in negative 7 multiplied by negative 3 plus negative 6 being multiplied by negative 7. Remember to go across the row from left to right and down the column from top to bottom. Now we need column 2. Again, go across the row and down the column. This gives us -7 times -1 plus -6 times -6. Now we can take and do the arithmetic to find the resulting 2 by 2 product. -3 times -3 is 9, plus 7 gives us 16 for row 1, column 1. Double negative here gives us 3, plus double negative here gives us 6, which gives us 9 for row 1, column 2. This double negative gives us 21, and 21 added to this double negative of 42 gives us the value of 63 to go in row 2, column 1. This gives us a double negative of 7 plus the double negative, which gives us 36. 7 plus 36 gives us the value of 43 to go in row 2, column 2. This is the end of the video on matrices and matrix operations. In the next video, we'll be looking at using matrices to solve systems of equations using Gaussian elimination.